Hello, my name is Angad Kahlon and I'm in Comp 380 at UFV for the semester fall 2023. And this is our first assignment, which is a programming assignment related to CSP or constraint satisfaction problems. So the abstract idea of this assignment is basically we have countries that have different states, provinces, or territories, and as it could be challenging to develop a map using a minimum number of colors, which is which is why in this programming assignment we are given that problem, and with the knowledge of constraint satisfaction problems that we have to develop a map using minimum number of colors and keeping constraints in mind. So the main constraint in this assignment is that we can have two adjacent provinces or territories having the same color. So, to implement an algorithm with CSP techniques, we were allowed to use Python or Java for the implementation. So, I chose Python. And so, basically, with the main algorithm in use is the backtracking algorithm and recursion, where the algorithm actively checks for the values before the current value, and then which leads to a possible solution to the country color mapping problem. So the main focus or problem I'm working on is the country color mapping problem, where we have the constraint that two territories or two provinces cannot have the same color. So I've chosen Canada for this assignment. So basically, Canada has 10 provinces and 3 territories listed here and their abbreviations. And when we say we can have two adjacent provinces or territories having the same color, so for example, Alberta right here cannot have the same color as British Columbia, Saskatchewan, or the Northwest Territories, as those three are all adjacent to Alberta. So, for colors in the assignment, will be using red, orange, yellow, green, blue, and purple as necessary or as many as needed. So there are many ways to go about this problem. We could use generating and testing, which is kind of like trial and error, but that takes up a lot of computational power. We could use search algorithms by treating this problem as a tree, and using search algorithms like depth first search and backtracking to find a solution, which is not always efficient, but that's the main solution where I'm going for in this assignment. And we could use consistency algorithms techniques like domain consistency or arc consistency, which simplify the problem before finding a solution, thus making it the most efficient way to find a solution. But they require preliminary work. So domain consistency, where you're removing all like the unnecessary values, so that can help make the search go faster. So basically, for the experimental setup, with the use of some logic, we can find out that the minimum number of colors needed is four, as at most you can have four provinces or territories adjacent to each other at a time. Therefore, when we're running the algorithm, we should see that there should be a maximum of four colors. So how the backtracking algorithm would work is it would start by coloring one region and then coloring the neighboring region. And by region, I mean a province or territory. So to color the neighboring region until it reaches a region which cannot be given a different color from its neighbor. When that case is reached, it will go back to the previous neighbor, hence the name backtracking, and give it a different color. If coloring the previous neighbor causes a conflict, then it keeps on going back in neighbors until all regions have a different color from the adjacent neighbors. So for input output interfacing, I've chosen to solve this problem using Python code in PyCharm Community Edition, the IDE. So for a user to interact with the system, they'll have to open the Python file and run the code with the solution presented in the terminal. So the given and assumed data that are included in the code is the Canadian provinces and territories, along with a multitude of colors. The multitude of colors is given by the user. It is assumed that oceans/sea separate provinces and territories. Therefore, provinces and territories that have a body of water between them are not considered adjacent. And I'll get back to that in a minute. The expected results include the colors of. So basically, what we're expecting at the end of this is that the colors of each province, after running the algorithm, where two adjacent provinces or territories cannot have the same color. So, but going back to the ocean and sea scenario, basically, if we have, like, for example, Prince Edward Island here, which is surrounded by water, it doesn't have adjacent um province or territory. Therefore, it can be its own. It can be any color, and there's no constraint on it. So if we look at our code, which is not a complete implementation, but we have um it's a Canada map coloring, so we can enter in four colors that we're going to use. So we're entering four colors because at maximum there could be four provinces and territories that are adjacent to each other at a time. So we could do red, yellow, green, blue. And basically, with the full implementation of this problem, this should return each province like it is right now with the color, one of the four colors, with no adjacent provinces and territories having the same color. So, in summary or conclusion, overall through this assignment, I got the opportunity to learn about CSP and how one implementation of that could be of the country maps coloring problem. So I chosen the country Canada with 10 provinces and 3 territories to use for this assignment, where the constraint is that two adjacent provinces or territories cannot have the same color. Using CSP algorithms such as backtracking algorithms, it is possible to derive a solution for this problem. However, not everything is always perfect, and there's always room for improvement, even in this assignment. So, suggestions for the future include creating a user interact GUI or platform, which allows users to see an actual map with colors. Um, and for the future, I'm fully implementing the algorithm. So, with this assignment, I got to gain a lot of knowledge of CSP, and these are my references. Thank you so much for watching.